Network connected. Okay, there it is, guys. Okay, this is what the signals look like. You can see some of the sensors working. Now the sensor density needs to be a lot higher than this, but certain fingers work, certain fingers don't. You can see it adjusting. That's pretty good. Because there's lots of gaps, there needs to be a higher sensor density, but it's my belief that once I improve the system, double the sensor count, it will work. I'm pretty excited. So let's do all of them. And it really matters where these are located. So there's just so much friction in this system, so much inaccuracies in this prototype, that really it's just a proof of concept, and most of these should just be on the bottom of the forearm, and there's a big gap on the bottom. I mean, there's just problems galore. But if this can do even detect a little bit of signal, then it's worth it, worth pursuing the next. So the signals are cleaner, as you see here. It's getting about 100 samples per second across all sensors. And so the top, the last system, is showing which finger I'm pressing. Again, they're Hall sensors. The bottom is showing the pistons and their connection to the skin. And you see some of them go up, not all of them go up. They might be adjusting very small. That's where the signal to noise ratio needs to be pretty high. But I'll do some interesting movements that are quick, and you can kind of see it's different. So as you see that, what is it, sensor 7 can see this middle finger. Now let's do the ring finger. Okay, so sensor 10 is moving. It's acting interesting now for that. It's a different type of signal. Kind of cool. Pinky, okay, sensor, it's doing something different. It's really hard to do. It kind of hurts. Do index. See, sensor 7 gets a lot of signal, but that's where I believe all of these combined should be able to give us discernible data. There needs to be double the sensor count. There needs to be some conformity, the distance between the sensors have from one another. And here, I'll just kind of show you what's happening with the pistons. So you can see how the changing of the different muscles are contracting for the system to do that. And since this is looking kind of cool, I want to put not just the cello, that's the first prototype. This is open muscle, and then have 5.3.0. That's, I don't even know, that's the first version, the first PCB I got. Version 1, version 5.3.0. You can kind of see the piston moving is what creates those bottom 12 signal. The top is the last system, which is the label acquiring system. And the signals may look kind of weak, but these are all raw. These are just a linear transform. So I think it's ripe for the harvest of machine learning to solve this problem. I'm going to increase the sensor density. I'm going to replace the complexity of the spring clevis pin system with just silicon, hopefully a molded silicon piece that will be in between the magnet and the Hall effect sensor. Going to use more than one microcontroller to control the whole band, and hopefully I'll have double the sensors, and work with it'll be a very heavily material science problem. But yeah, I just want to invite anyone. This is open source, free for all humanity. It's hopefully meant to help people. Again, I think the purpose in life, from what I can understand, is to increase joy and decrease sorrow as much as possible. And that's what I'm trying to do with Open Muscle in the system. So please join me if you have ideas. I'm going to continue working on this for however long it takes, till hopefully it takes off and it can go into the community's hands and I can focus on something else. Or because I have some other ideas that I want to help with different type of disabilities. And that is it's kind of a glitch. I tried to decrease the noise but you can guys kind of see the system. It's a prototype. It's not meant to be like solve the problem directly. It's meant to say that, hey, it's possible to glean these. One of the problems is that someone that has their hand amputated, if they have the forearm, this is kind of what's for, is a partial amputee. The tendons won't be attached to the muscles. The muscles will still contract. But you might have to actually train the system with another hand, do a mirror thing. So, you know, if they don't have both hands, maybe machine learning can solve this problem just with enough data. And yeah, that's my belief. And again, the signals are interesting. There's noise in the system, of course. There's room for improvement. It may not seem like a lot of movement, but this is kind of what I believe the desired output would be with a pretty, very, very humble working prototype. So the signal may not look loud, but again, the difficulty is with getting these spring tensions and the band tension. So I think this can be solved more efficiently and more linearly with a material science approach with some type of mono substrate, some kind of substrate or some kind of spring system like silicon is my belief. So yeah, that's my open muscle update. I'm going to start the machine learning regression algorithm, see if I can discern what fingers are moving what. This data is live on GitHub. This video too, so you can see the video. My idea is to use, I want to make in the future a system of optical LASK or optical LASK system that can do the label acquiring through another visual machine learning. It's a gesture recognition. Because as you'll notice, if I just move my fingers, it also creates some signals here in the band at the bottom. And so if you apply a force, it's a certain type of movement. If you just move your finger with no force, it's a certain type of movement. There's also some interesting muscles that only if you're doing some fine motor control. And this is only 100 samples per second. So maybe we can increase the sample rate. Maybe we can do some other things. But this whole platform is open source, GNU, public license. Do with it as you wish. I don't think this version is very good for the actual problem. It's good just for me, for testing the machine learning process. I do want to have the 2x2 cells. And right now the pitch in between the sensors is 15 millimeters. Maybe the pitch can be decreased, but as the pitch decreases, the sensitivity of the spring needs to be lower, right? Because it's spread across all the surfaces. So I don't know. It might not work. I believe that there is a lot of potential. What do you guys think? Let me know in the comments. Like or subscribe. I post silly videos about all the stuff that I work on. I try to work on open source products and just doing my thing. But as always, I'm going to leave off with let's see how big of a positive dent we can make in this world, guys. Join me for future updates. TURFPTAx out.